Good morning. Today we're going to be talking about solving problems that have radical signs, which we've kind of done this with Pythagorean theorem and some of the other problems that we've encountered this year already. So you'll see that the radical sign, like number one, is like, I'm hoping is an easy one for you on the warm-up here. It says, which of the following expressions is a radical expression? So all we're looking for is the radical sign. This is a linear expression because I have just an x there. This one's a radical because I have the radical sign here. This one's a quadratic. This one's a quadratic. Again, they're quadratics because I have the x squares there. Okay. If you remember back to Pythagorean theorem, when we wanted to get rid of a square root sign, we squared both sides. And so I'm hoping that you remember that this guy and this guy cancel each other out. You can try it on your calculator that if you take the square root of 5 and then square it, your final answer is going to be a 5. You probably are going to do that on your calculator. Try it. All right. So then over here, again, this is square the whole thing. So we can just cross these off and just say our final answer is x plus 2. Now, not so much today, but tomorrow we're going to go back to factoring these guys, and we'll do a little bit today. I think one, maybe two problems, but we can't forget how to factor quadratics. And so I'm hoping that you remember that if it's an x squared, that it's an x times an x. And then we need two numbers that add up to 6, but multiply up to 6, but add up to 5. And so our two numbers are 3 and 2. And both of them are going to be positive because they'll both add up to 5, and 3 times 2 is 6. But we're not done yet, because then we have to set them to 0, if you remember. And then we subtract 3 from both sides, and we talked about taking a shortcut as long as you were careful, that our two answers are minus 3 and minus 2. Okay, so try number 5 real quick. I have the answer on the next page here. And let's see how you do. All right, let's see what I got on that one. I got a positive 7 and a negative 2 were my two answers. Okay, hope you did too. All right, so today again is just kind of pretty simple. To get rid of a radical sign, all we want to do is square both sides. The opposite of multiplication is division. Opposite of addition, subtraction. Well, the opposite of a radical is square. What I do to one side, as long as I do it to the other, our equation's still balanced. So we get into this habit and make sure that you show that this cancels out with this, that we just have an x. And our final answer is just going to be 49. That makes sense. If I put 49 in for the x, the square root of 49 is 7. So again, square both sides. These two cancel out, that we just have 4x. And over here is 144. I have no idea what 144 divided by 4 is. And I'm getting 36. Okay, so those are the nice easy ones. Now, let's just kind of move it up a little bit. I'm sure you can do these as well because it just involves a little bit of algebra, isolating the variable after we get rid of the radical sign. So we're going to square both of these. So then I have x plus 2 because the radical sign just canceled out. And all I have to do is get the x by itself. Okay, same thing here. I'm hoping that this part in your life is kind of pretty easy now that we add 6. 64 plus 6 is 70. Get rid of that 2. I want to multiply both sides by 2. And get next is 140. Okay, so it's just basically algebra, basic algebra, getting the x by itself after you get rid of the radical sign. All right, do these 4 real quick. Pause your video and then come on back and let's see how you do. Here's what I got for my answers. I got first one 64, next one's 50, 114, and the last one I got 63. If you didn't get those, pause your video and then just kind of look and see, follow my work along there and see where you might have boo-booed. All right. Now, sometimes a radical sign isn't by itself. And so in math, when we're solving radicals, before we can square both sides, we got to get it by itself. Okay, that's kind of the rule. So to get this radical by itself, we're going to add 5 to both sides. So now I got square root of x equals 13. And now I can take the square of both sides and really get in the habit of showing the radical sign and that it's canceled out there. Okay. And then I got 13 times 13. 13 squared is 169. I just want to make sure. All right, so let's see now over here. I'm going to subtract 5 from both sides. Now I got square root of x equals 3. We'll square both sides. I'm getting x is 9. Again, we can put that in. Square root of 9 is 3. 3 plus 5 is 8. So I'm 100% sure that that's the right answer. All right, that was not a lot of growth there or extra steps. So kind of do these 4, and let's see how you do. Okay, let's see how you do. I got 121 for the first one, 49, then 36, and then 1,296. Okay. All right. Let's go a little bit more involved here. So when I have square roots on both sides or one side and I have 2 square roots, I want to try to get them, split them up, that one's on one side of the equation and one's on the other one. So this one's already set up that if I squared both of these guys, well, this would cancel out with this, and this square would cancel out with this, and then the square root signs go away. And now it's just this basic, let's get the x by itself. Again, I like to keep my x's positive. We'll flip my equation because now we should be okay with that. Soon to be 10th grade. Okay. On this one, though, to get my radicals on the other side, it doesn't matter which one you get to the other side. I'm just going to take this one. I'm going to add 2x, square root of 2x to both sides. And now I have a radical on both sides. Now I can square both sides. And I got an x plus 2. And then on this side, these cancel out. And so I got 2x. You know, I like to keep my x's positive. Don't have to. No big deal to have a negative and then divide by a negative or multiply by a -1, okay? Just seems to skip an extra step if we keep them positive, okay? All right, give these 2 a shot real quick. We're moving right through this lesson today. Okay, let's see how you did on these 2. Look at that, I got 2 for both of them. Interesting. Okay. All right, let's move on and wrap this up here. Now, we call this an extraneous solution. Not all these numbers that we're getting here will work. And so sometimes we'll get an answer that's not a plausible answer. And so watch how we go about this one. To get rid of this radical sign, do you agree we'd have to square both sides? This is kind of more what we're going to do more of tomorrow. This is really what we're supposed to work on today. I wanted to review all that other stuff. And so when I do this square over here, I got to square this whole thing. So I have x minus 1 on this side because this cancels out with this. But over here on this side, I have x minus 3 times an x minus 3, which we need to know FOIL. Some of us already know about, it's going to be an x squared minus 6x plus 9. Now on this side I have an x minus 1 still. And if you remember, when we're solving quadratics, we want to get everything to one side. So I'm going to add 1 to this. So then I have x equals x squared minus 6x plus 10. Let's get that x to the other side. So now I got x squared minus 7x plus 10 equals 0. And can't forget how to factor. See, I need two numbers that multiply to 10 but add up to a negative 7. So I'm thinking 5 and 2 might do it. And I'm thinking both of them have to be a negative. So that would give me a positive 10 and a negative 7. Now, I want to do some mental math here. I'd set both of these to 0. So one of my answers is going to be a positive 5 and the other one's going to be a positive 2. So those, I think, are my answers. Now, we haven't practiced this very often, but I want to go back and check because sometimes, especially when we're factoring, one of these answers might not be a plausible answer. So let's go back and check with the 5. I have a 5 minus 1 square root equals 5 minus 3. I'm plugging the 5 back into the original equation. So I get square root of 2 equals 5 minus 3 is 2. And, how about 4? That's a 4. Square root of 4. And I know the square root of 4 is 2. So 2 equals 2. So 5 is an answer. Okay, let's try the other one now. Square root of 2 minus 1 equals 2 minus 3. Well, that's a minus 1. 2 minus 1 is 1. The square root of 1 is 1. And 1 equals negative 1 is not true. So this one is not a solution. So the only solution is 5. Okay, we call that other one an extraneous solution. Okay. All right, here's our area. Area equals base times height. Again, we should know this quite well by now. So they said in this, our performance center, the area of the center is 30 square decimeters. So they said square decimeter, so I know that's the area answer. And my base times my height. Now there's two ways you can do this. You can take this times everything here, but I noticed on my length here, it's x square root of x this much and then minus square root of x. And if I put these two guys together, well, basically they cancel each other out. So really my base is just a 6. So then I have square root of x times 6, base times height. Well, I want to get that x by itself, or the square radical sign, square root sign. So I want to divide by 6. So now I got 5 equals the square root of x. If I square both sides, I got x equals 25. Let's see if that works here. By square root of 25, that would make this side 5. Square root of 25 is 5. And then 6 minus 5 would be 1. So that'd be 5 plus 1 is 6. Now if I took the base times the height, base is 6, height is 5, 30, and I get 30 like I needed. So let's see the area of the center. What's the question here? The area of the gallery. So just x equals 5 decimeters. Decameters, I guess the way you say it. 25 decameters. Okay. All right. So today, most of them are pretty simple. I don't think you have any where you have to do some factoring. We'll save those for tomorrow. And just sometimes you'll have a no solution. So If you have a negative underneath the radical sign, well, that would be a no solution. There was a mistake on the paper. If you'll add to your practice sheet an X here, I want to make sure that we don't forget how to do these, guys. Okay, for our test on Friday, we have a test on Friday, so we want to make sure that we don't lose some of those skills every day. Okay. All right. With that, I'm hoping to see you tomorrow.